Now our third point is electrostatic potential due to a system of charges. First upon we see the point charge, then electric dipole, and then now system of charges. Now what is the system of charges? This figure shows the system of charges. Means here Q1, Q2, Q3 up to Qn charges shows here a system. Here figure shows a Qn is a system of charges. Means we now extend analysis to system of charges. Now here middle point is P point. Okay, so we are considering a system of charges Q1, Q2, Q3 up to Qn at a distance R1, R2, R3 up to Rn respectively from point O, and the potential V1 at P due to the charge Q1. Now we are find out now here potential from charge Q1. Similarly, we find out a potential from at point P from the charge Q2, and similarly for Q3 up to Qn charges. So here V1 is equal to 1 upon 4 pi epsilon naught Q1 upon R1 because of charge Q1, and similarly the potentials V2, V3 up to Vn at point P due to the individual charges Q2, Q3 up to Qn are given by. It's the same expression for the potentials. So V2 is equal to 1 upon 4 pi epsilon naught Q2 upon R2. V3 is equal to 1 upon 4 pi epsilon naught Q3 upon R3, and up to Vn number of charges is equal to 1 upon 4 pi epsilon naught Qn upon Rn. So by the superposition of the principle, the potential V at P due to the system of charges is the algebraic sum of the potentials due to the individual charges. Okay, so therefore V is equal to, means potential at point P is equal to V1, V2, V3 up to Vn charges is the addition. So V is equal to V1 plus V2 plus up to Vn charges. Then putting these equations or values of V1, V2, V3 in this equation, then we find out a similar point in this equation is 1 upon 4 pi epsilon naught, and in bracket of Q1 upon R1, Q2 upon R plus Q2 upon R2 plus up to Qn upon Rn. So we already know that summation means addition means the summation of charges. So we get here V is equal to 1 upon 4 pi epsilon naught summation of I start from 1 to n number Qi upon Ri number. So for the continuous charge distribution, summation should be replaced by integration. So integration to 0 to n charges. Okay. So here our points are completed. Here 3 points are complete. In last 2 videos, we find out 3 formulas. First formula, electric potential due to a single point. So if we get here V is equal to, means potential is equal to work done is equal to Q upon 4 pi epsilon naught R. This is the first formula for single point. Then second formula for electric potential means V due to an electric dipole. So here Vc is equal to 1 upon 4 pi epsilon naught P cos theta upon R square. This is the second formula. And third formula for the electric potential due to a system of charges. So we get here V is equal to 1 upon 4 pi epsilon naught summation of Qi Ri. I start from 1 to n number. We get here 3 formulas. Now for the electric potential. Now find out our next point is electric energy of point 2-point charges and our dipole in an electrostatics field. Okay, so this equation find out first expression for potential energy of a system of 2-point charges. So the electrostatic potential energy of a system of point charges is defined as the total amount of work done to assemble the system of charges by bringing them from infinity to their present locations. So see this figure first. So here x, y, z coordinate system, and here A and B places a 2 charge and the distance from the center of coordinate system to this position of A and position of B. So this system for the 2-point charges, we are considering only here 2-point charges, means A and B, and distance OA is R1 vector and OB is R2 vector. Here R1 vector and R2 vector shows a position vector. Here shows a position vector, not a magnitude, only position of the particle. Means here at A point situated a position of particle and at a B point shows the position of particle. So let us consider two charges Q1 and Q2 with position vectors R1 and R2 related to some origin O. So to calculate the electric potential energy of the two charge system, we assume that the two charges Q1 and Q2 are initially at infinity, and in bringing the first charge Q1 to position A, R1, no work is done because there is no external field, that is W1 is equal to 0. Then Q1 charge produces a potential in space given by V1 is equal to 1 upon 4 pi epsilon naught Q1 upon R1. Means at this first condition, means A is situated at this distance, position vector is R1 vector. Now this is a single charge Q1, not any charges exerted a force on these charges. So this force Q1 charge exerted a force only, not any external force applied by this Q1 charge. So we get here only a potential is for the A position. So we get here formula V1 is equal to 1 upon 4 pi epsilon naught Q1 upon R1. Okay. Then when we bring charge Q2 from infinity to B, means R2, means infinity to origin, then at a distance R12 from Q1, work is W2. Now here for second charge Q2 situated at point B, means come from the infinity, means from long distance to come from a B point, then here this charge also exerted force on the surrounding, and this A charge, means Q1 charge, exerted a force on B1, B position charge, means Q2. So Q1 charge exerted force on Q2 charge. Okay, first positions here a single charge, but now here second position means at B position this produces a charge, and also this Q1 charge exerted externally force on Q2 charge. Okay, So we get this work is done because any force exerted a force to another charge, means this charge exerted on this force and this charge exerted a force on this. So here work is done. So W2 is equal to potential at B due to a charge Q1 into Q2. So formula for potential is for Q1 charge Q1 upon 4 pi epsilon naught R12, because here 1 2 into Q2. So this work done nothing but energy, because this work done is stored in the form of potential energy. So work done is equal to potential energy, means U, because energy denoted by U symbol. So U is equal to Q1 Q2 upon 4 pi epsilon naught R12. Okay, we get here potential energy for a 2-point charge. Okay.